First LEGO League is a fun, exciting, mentor-based experiential STEM program for kids ages 9 to 16. It's an alliance between FIRST, an international organization to inspire young people founded by Dean Kamen, and the LEGO Group. It's one in a progression of 4 FIRST programs designed to foster 21st century life skills and spark kids' interest in science, technology, engineering, and math, so they become innovative problem solvers able to tackle the world's biggest challenges. Each year, First LEGO League teams are presented with a real-world theme, like transportation or waste management. Over a minimum 8-week season, they select and research a problem based on the topic, then devise innovative ways to help solve that problem. Teams also build and program a LEGO Mindstorms robot to solve a series of robot game missions, all while practicing the signature core values, which emphasize good sportsmanship and having fun. If you'd like to get involved with First LEGO League in your area, visit us online.
All right. And sorry if you guys, I don't know if it's raining where you guys are, probably, but it's kind of raining here in the background. So if you guys hear the rain, just know it's kind of heavy. So yeah, that was just kind of like an overview on what FLL is. So basically, like the video, I think did a perfect job of kind of explaining it. You build a robot and you compete and you do a bunch of other stuff. So the robot, building the actual robot and competing is just one aspect of FLL. You also have the judging rooms, and you have to do a bunch of different stuff there. So you have like you have to, like I think it said, you have to solve a problem. So you have to like make a project, and whatever the theme is that year. So this year was like RePLAY, right? I haven't been really keeping up with it, but you have to solve whatever problem. You have to first create like or find a problem and then solve it, and then just kind of put it into a project type of form. And you have to like get poster board and do all that stuff. So it's kind of like I wouldn't call it a science fair, but kind of like if you guys have ever done science fair, it's kind of like that. So you have to like find a problem and then kind of do stuff to solve it. And that might require you guys like doing experiments or like researching, or I don't know, going out in the community and doing stuff. Like I know a team last year, their problem was like trash in the community in Jacksonville. So they went out and picked up trash at parks and stuff like that. So that's the kind of stuff that you do. So building the robot and competing, that's just one part of it. I think I talked about one of the judging. Let me see if I can pull it up. So, well, judging. Right there. So those are the different judging rooms. So you have core values and the robot game, and then your actual project. And so with core values, it's just kind of like how well you like work with your team, and if you guys are like a team, if you guys work together well. So in that room, and this is actually kind of fun, you'll be tasked to like do something. So maybe it might be like a game or something like that. So they might tell you guys to play a game together, and they want to see how well you guys work together. And that's just to see if you guys are like an actual team, or if you guys are kind of just like individuals just working separately. And again, I talked about projects, so you have to choose a project that's kind of like with the theme of that year and work on it and like research. And then the robot game. So that's the third part. The robot game is building the actual robot. That's what you probably spend most of your time doing. And so like these two other stuff, this won't happen until you actually get to a competition. You're always going to be working on your robot, like building your robot. And of course, you'll probably be working with the team, the core values, and doing your project and working on your project. But you won't actually present all that stuff until you get to a competition. So this is kind of like the final result, what you're going to do like once you're at a competition, and if you like move forward, what you'll continue to do. Yeah, so if you guys have any questions, let me know. But that's just kind of like basically what you guys are going to be doing. Oh yeah, and I think I forgot one, robot design, and that's part of the judging. But you get judged on your robot design. You have to like explain why you put some stuff and like why you didn't, and like why you have, I don't know, why you have 2 large motors instead of 3 or something like that. So you just explain your design, and then they judge you on your design. Yeah. So let's watch this year's video.
But Grammarly
Oh,
can
and you
help.
guys know that you guys know all about FIRST, right?
Yeah. It
Karen,
says,
do you know about FIRST? Because I think there's a video for that as well.
wait, I know what,
Yep. Oh,
oh,
maybe we got
wait,
disconnected. So FIRST is just like the in the broad sense, the organization that puts all this stuff together. So you guys know that FLL is just one like competition set. So you have FLL Junior, which I think some of you guys have done or like kind of played with, like the We Do. That's FLL Junior. Then FLL, which is what you guys are going to start doing now, which is with actual Lego EV3 and Technique pieces. Then you have FTC, so First Tech Challenge, and that's kind of like a step up from FLL. So it's around like I think it's from 7th grade throughout high school. So I think you have to at least be in 7th grade, and then as long as you're between 7th grade and you're in high school, then you can do FTC. And with FTC, you actually start to build like metal robots. So they're you don't no longer use Lego. So Lego is only for FLL Junior and FLL. FTC uses metal robots, and you start using metal parts. And then the last one, FRC. So FRC is like the last level or the highest you can get in FIRST, and that's you're still building metal robots, but they're a lot bigger, and you'll probably see a lot bigger teams. It's like FTC but bigger, and FRC is only for high school, so you can't be in 7th grade or 8th grade. So it's only just for high school, and that's actually the team I'm on. So if you guys know Team Resistance, that's an FRC team. And so they build bigger robots, so really big robots. So some of the robots might even be as tall as you sometimes, whereas FTC is a lot smaller. The robots would probably just be kind of like on the ground. It probably won't be that tall.
what? Wait, robots as tall as us.
Yeah, I mean, you guys are like, what, in 5th grade, 4th grade? You guys aren't that
Yes.
tall yet.
No, like 4'9".
Yeah, Team Resistance has some really tall robots. Maybe like, I want to say like 5 foot, maybe.
Oh my god.
Here, I'll show you guys FRC
In
robots.
second grade.
Oh, wow, you're in 2nd grade? Then there are definitely robots taller than you. Yeah, so like this is probably, I want to say, at least 4 feet tall, at least. And if you want to compare it to FTC, you can definitely see the size difference. So look at that. These are a bunch of FTC robots.
Oh yeah, but it.
And then FRC, like these are really, really tall. Let me see if I can even find Team Resistance. Yeah, these are some of our robots, and these are actually kind of some of the smaller ones. Like this one is a little taller. And so just like look at size comparison. So you can see how everyone's standing and some people are sitting. So some of these robots are taller than the people sitting.
Wait, so you build robots out of like pure metal and wires?
Yep. So it's all like real world kind of stuff. So you have to like actually build with metal. You have to first cut out the metal. That's the difference. I'm not too sure about FTC, but I'm pretty sure you don't have to like use machines to cut out metal. I think everything is like, I'm not sure if they use Vex or Rev. I don't know. I don't really know that much about FTC, but I'm pretty sure you just order the metal parts. But in FRC, you actually have to cut out the metal part. So you have to make your own pieces. So they're not just there. Like they're not just Legos that you can use to build. You have to actually like design it and then cut it out on a machine.
If you
It's pretty
ever
cool.
like find the pieces, you can build a robot at home.
What was
Like-
that?
So if you like ever find like the pieces and like you have all the motors and wires and stuff, you can build a robot at home apparently.
With FRC, I doubt that. I mean, unless you have a big CNC machine in the back of your house, I doubt you're gonna be able to build an FRC robot.
Well, like
They're
maybe
really, really big machines. What was that?
maybe like a tiny robot.
Yeah, you probably could build a FTC robot at your house if you like order like Vex parts and stuff.
Nice.
Actually, I think I have a Vex kit. Yeah. All right, so let's watch this year's
This sentence is grammatically correct.
And again, let me know if the volume is okay.
For centuries, sports have played an integral part of our culture. Moving, collaborating, competing, celebrating. Sports have paved a way for us to play and move together. The activities that challenge us physically and mentally are shifting, and we are challenged our minds, our creativity, imagination, and critical thinking as much as we use our muscles. As we rethink where we move and redesign the parks, fields, and spaces around us to create places to play, we have the power to be forces for change and redefine the game. Let's work together to champion every sport and every person that plays the game, so people of all abilities and skill levels can participate, giving us all reasons to cheer. It's time for us to revolutionize the way we play and move. It's time to be game changers. In the 2020-2021 first LEGO League Challenge season, RePLAY, you will explore opportunities to play and be active. More and more people are not active enough. Playing makes being active more fun. You get creative when you want to play, and it's this creativity, your creativity, that can help motivate us to be more active. How and where can we help people be more active? How can we motivate our community and impact the future? What solutions can we create now to help everyone to a fun and active future? Every role on your team is important to help solve the problem. It will take teamwork, imagination, and creativity. And it starts here, with your critical thinking and imagination leading the way toward fun and active lifestyles for everyone. You will also learn about the first core values. The core values are part of everything we do at First. They are like the members on your team. Each one works together to help you succeed. Discovery, innovation, impact, inclusion, teamwork, and fun. The core values should be a part of your first LEGO League experience. Use them throughout the season. Your innovation project is one component of the first LEGO League Challenge. Identify a specific problem linked to people not being active enough. Research your problem and your solution ideas. Design a new piece of technology or improve an existing one. Make a model or prototype to show how your solution helps people be active. Share your solution. Collect feedback and iterate on your design. Pitch your solution at an event. Make sure your whole team is involved.
This is the RePLAY competition field. There are 14 missions, which can be attempted in any order. You do not have to complete all the missions, just try as many as you can in each 2.5-minute round. Only the score from your best round will be counted. Your robot must start from this launch area, and you should program it to return to this home area when it returns from the field. You can handle and modify your robot while it is in the home area. If your robot and all its equipment is small enough to fit in this small inspection area, you will score 25 points. Mission 1, Innovation Project. During this mission, you will use the white brick model that you have made that represents the solution to your innovation project. The robot moves your white brick model into the RePLAY logo, or to the gray area around the bench. Mission 2, Step Counter. The robot slides the step counter slow and steady. The further it moves, the more points that are scored. Mission 3, Slide. The robot slides the people off the slide. and moves them to other areas, completely in home or on the heavy tire. Mission 4, bench. The robot flattens the bench, removes the backrest, and gets cubes into the hopscotch spaces. Mission 5, basketball. The robot gets a cube into the crate and raises the crate up the basketball post to the middle height, or to the top height. Mission 6, pull-up bar. The robot passes completely under the bar in either direction, then later comes back and lifts itself off the mat at the end of the match. Mission 7, robot dance. If the robot is dancing on the dance floor at the end of the match, Mission 8, Boccia. If both share models have sent only one cube anywhere into the opposing field, and those cubes color match each other. If there are any color cubes in your frame or target. And if there is at least one yellow cube completely in your target. Mission 9, tire flip. The robot flips tires white side up, the heavy black tread tire and the light blue tread.
Hey guys, today we are trying Adapted Mind. I'm so excited to try this game. I've heard
Tread tire. If the heavy tire crosses the red flip line at any time, it scores 0. The robot moves the tires into the large target circle. Mission 10, cell phone. The robot flips the cell phone white side up. Mission 11, treadmill. The robot spins the rollers to move the pointer clockwise. The further it moves, the more points scored. Gray, red, orange, yellow, light green, or dark green. Mission 12, row machine. The robot moves the free wheel out of the large circle and into its smaller target circle. Mission 13, weight machine. Before the match, set the weight machine to the color you want, blue, magenta, or yellow. During the match, the robot forces the large lever down until the little yellow stopper falls to score points. Blue, magenta, or yellow. Mission 14, health units. The robot collects health units from around the field, then moves them to target areas, touching the RePLAY logo, touching the gray area around the bench, or looped over the pull-up bar post. Mission 15, precision. If you interrupt your robot, you will lose a precision token. Precision tokens left on the field can result in extra points. Remember to read the robot game rules and check for any updates during the season.
Good luck this season, and remember to have fun as you reimagine the way we play and move. Whether you're exploring how our bodies move or uncovering opportunities to play that are fun and fair for everyone. Your creativity can revolutionize the world. Let's rethink the way we play and move. It's time to be game changers.
All right, so I hope the audio is good, but that's this year's video. So they do this every year. They give you
Collaborating.
like a, it's not really general, but they give you like a detailed like look on about what this year's like theme is and like what the missions are. So this year, I think they said it has there's 14 missions. So there's 14 different tasks that you can do, and you don't have to do
Writing's
all
not
of
that
them.
easy.
But you want to do as many as you can to score the most points, because that's how you win, or that's at least it adds to your total score. Again, building a robot and competing isn't just the only aspect of FLL. So you want to get a high score so it can add to your other scores. So like I think we talked about core values and the judging rooms. So you want to do really good in your robot game, especially if you know that's probably going to be one of your strengths. And so even if you don't do good with a robot, you can still get awards and stuff for like other aspects of the competition. So even if you have a bad robot, you can still get an award if you have good teamwork skills and you do good in core values, or if you have a really good robot design, you can still get points and stuff like that.
Shade.
Yeah.
So are we gonna be building the robot over there? Or are we gonna have it built like already?
So from what Coach K is telling me, it looks like we're going to be kind of working on the missions and I guess building mechanisms. So think of it more as like we're going to be building parts for the robot.
And then we're gonna combine them all.
Yeah. So we're going to be building parts for the robot, and that might require us like building something. I'm thinking it's going to probably require us to like build a part and then like catalog it and like take a picture of it and stuff, and then disassemble that part and then work on something else. So I think we're all going to be like, maybe one day we might all work on one mission and then like build a mechanism. Everybody will build their own separate mechanism, and then we'll see which one works the best. And then if we decide on that, we can continue working on that one or move on to another one, and then we'll just keep on going like that. So hopefully at the end, or at least during quarantine, we should have a bunch of different mechanisms and a bunch of different parts that we are going to add to our robot. So then when we all are together, then we can like build the actual robot, if that makes sense.
Yeah, that makes sense.
Yeah. So I think that's what we're going to be doing. So we're not going to be we're just building the parts for the
We're
robot.
not going to be programming that much. We can test this out using motor control.
No, you're still going to be programming a lot. I mean, think about what you guys are already doing now. You're probably going to be doing that, but it's not going to be like there's instructions. So I know you guys we've been building with instructions and stuff like that. That's probably going to be the only thing that's going to change. So probably, and actually the programming might change a little bit. So it'll probably be more of you guys are doing a lot of independent stuff and collaborating and then working on building something and then programming it, maybe programming it independently or program as a team like we are currently doing. So it's going to probably be more like that. So we'll still be programming a lot, because if we're trying to build parts of the robot to use as a whole, then we want to have those programs ready so that when we do come together, we can put those we already have the programs, like design, if that makes sense. We already have the programs for that certain mechanism or that certain part.
Oh, okay. Well, how are we actually gonna, so either we're gonna take like a bunch of pictures of the program and like,
Oh yeah, that's the program. The programming is easy. I mean, when we program with MakeCode, all we have to do is download it. Whatever software we're using, you'll be able to download the program and actually maybe like save it to a USB or something like that. and it should be on your robot. So yeah, the programming is fine. We can save it like that, or we can take a picture of it or something like that.
Screenshots.
Yeah. And if we have a certain design that we like, we can maybe, if someone wants to take the wheel and maybe download one of the 3D modeling softwares for Lego, you guys can do that. Or if you guys need help with that or something like that, we can all make designs and stuff.
Wait, we can 3D print our own Lego pieces?
No. There's a it's called LDCAD or L3D CAD. I forgot. LDCAD, something like that. LDCAD, yeah. So it's a modeling software, but just for Lego. So think about Tinkercad, but instead of having like squares and stuff like that, it's just
Lego pieces. You're breaking up, Coach Aid, a lot.
Lego. So all of your shapes, is it good now?
No, sort of.
Okay, let me try to switch internet.
Oh, there we go. Now you're awesome. Now you're fine. Connection is now good.
All right, is it good now?
Yeah.
All right.
So can I like basically like take a bunch of screenshots of this and then like make a PDF out of it?
You can make instructions, but that might take up too much time. Like if you already have the 3D model, you can go into the software and look at where you put each one and then just build it from that. It might actually be a lot quicker than making instructions, because when you make instructions, you have to format it and do a bunch of stuff like that. So it might just be helpful to just have the 3D model so you can see it in 3D.
Now, if you like just wanted to do it like in your spare time.
Yeah, if you guys want to do that in spare time, go for it. But as a team, you probably might not do that because it probably takes up a lot of time. I mean, designing with the software takes a lot of time by itself. You guys haven't done it, but I've played around with it a couple of times. Like if you want to design, it takes probably almost the same amount of time as it does to come up with an idea and actually design something. So it does take a while because you have to drag out each individual part.
And it probably wouldn't snap very well, and you would have to like.
It snaps very well, but I mean, you might have to like rotate a part or something like that, and it does take, the time does accumulate, so it can take a while. Yeah. So did you guys have any questions about FLL in general or this year? Nope.
No, I don't think so.
Okay, and there's it should be online, but there should be like a booklet of all the criteria and stuff and an explanation of all the missions, so you don't always have to go back to this video. And it should be somewhere. I don't know exactly where it is. It should be on the website, but it should have like all of that stuff. And there should also be a website that gives us updates, because sometimes they do like to change things around. So they might like change how many points a certain mission is. And so all the missions are worth different amounts. So you might want to go for and of course, probably harder missions are probably going to be worth a lot more because they're harder. So if they change that stuff, you definitely want to know, because it might affect how you run your robot or what your priorities are.
The hardest one that I saw had like 60 points for it.
Mm-hmm.
And it was like,
yeah.
I don't know which one it was, but there was one with 60 points.
Mm-hmm. Yeah, for me, the hardest one looked like the pull-up, the one where you have to hang yourself. And that's actually something that they borrowed from like FTC and FRC. They usually tell you, like, I know last year's game for us, for FRC, you had to pull yourself up and you could get points from that. And you actually had to, it was like kind of like a seesaw, and you had to pull yourself up and the other robot had to pull themselves up, and you had to balance each other. But that's the hardest one I saw, because that robot, I mean, it's a Lego robot. It's small, but on a Lego scale, it will probably weigh a lot. Let me see if I can find it. This one, yeah.
Yeah.
It's only worth 30 points, which is kind of crazy. I think it'd be worth a lot more than that.
Wait, that just looks like the EV3 brick.
Yeah, that's just I guess at first was kind of being lazy. That's just a sorry, the what's it called? The Spike Prime. That's the Spike Prime little module or the brick or whatever you want to call it.
What if the whole thing collapses and your robot has like 10 motors on it?
If it breaks, well, then that's a problem that you have to fix. Because if it breaks, then you.
Wait, not like the robot. I mean the mission itself.
Yeah, that's what I'm saying. If you are testing your robot and you see that it's breaking the pieces, you have to make your robot lighter, or you just don't go for that mission. Because they said you have to do this one at the end. And I mean, it doesn't make sense to do this anywhere but the end. Because if you hang yourself, I mean, you still have to complete missions. And I don't think it mentioned, but you have to do all this in 2 minutes and 30 seconds. So that's how long, when you actually are running your robot, you have 2 minutes and 30 seconds to do as many missions as you possibly can. And so that is very short of a time, considering like all the months you spend working on just those 2 minutes and 30 seconds. But I mean, in the end, you'll have a refined robot, and you have as the maximum amount of missions that you can possibly do.
There is multiple rounds, right?
Yes, there's 3 different rounds, and they take the highest score. So if you score, I don't know, like 5 points in one round, and then you score 200 in the next, they take the 200. So it's the highest out of the 3. So you have 3 chances to redeem yourself, because they understand like things can happen. Like I'll share with you guys now, but last year the team that I coached, Master Builders, their robot like messed up on 2 of the rounds, but one of them was good. But yeah, you can have some slip up sometimes. Maybe the brick, I don't know, doesn't work or something like that.
Technology doesn't always work.
Yeah, Lego can be funny sometimes, and I think it's like that with all of the different competitions. So FLL, FTC, and FRC. It's not just a one shot. You have multiple rounds. Yeah.
Like in programming, is there a way to switch between 2 programs without touching the brick?
Without touching the brick?
Like, like without pressing the buttons.
I mean, of course. I mean, if you have 2 different programs and you want them to run like chronologically, then you're really just putting it in one program, aren't you? Like if you want the robot to move forward and then turn right, you can kind of think of that as 2 separate programs, but then you could just put that together. Is that what you're asking?
Yeah, but then like when we did the puppy sort of.
Yeah.
How it like sort of overloaded and it couldn't handle it. Like if we had like 3 separate programs, each for like one where we like one for each color, I feel like it would handle it a lot more better.
If you had individual programs for each, well, that was just a make code problem. I don't know. It had to do with the moods and the sound. I don't know exactly what the problem was, but it was definitely something that make code needs to fix. So something with that. It shouldn't be a problem. I mean, it shouldn't be. Yeah. I mean, you can switch between programs, and that's actually preferred, because I think they mentioned at the beginning that every time your robot runs and it's coming back, you can't touch your robot until it comes back to the sort of home area. And I think they showed that. Yeah, so it's it's like the semicircle and everything in the black.
Mm-hmm.
So this semicircle and then everything here. So your robot has to be in here and I actually think it's just the black for home, but your robot has to be in there for you to be able to touch it and switch programs. But like if you want to go out and do one mission and you want your robot to come back, you can do that and then switch programs really quickly and press it and then have it go out again. And so the reason they have that is because like if you have all of your missions programmed in just one big program, there's a lot of chance of error. Because think about it, if you're doing there's 14 missions, if you're doing 10 out of those 14 missions, say something messes up on mission 5, right? Everything in your program depends on mission 5 working, if that makes sense. So if you mess up on mission 5, everything is it's just not going to work. So that's why it's probably preferred to go out, maybe do 1 or 2 missions, come back, and then switch to the next.
But that might waste a little bit of time.
It does, but trust me, it's worth it, because things can mess up. if you understand what I'm saying, you don't want to go out and do all of your missions, because if your robot messes up on mission 1 and like accidentally, like, I don't know, hits a wall or something like that, it's now off track. Because when you're programming it to say go left and then go right for 1 rotation. If it messes up and then it doesn't move that extra 1 rotation, everything is going to be off by 1 rotation, and it's not going to be able to do the other missions.
Or like I have this problem where like you run some motor and like the code depends on all of it running the motor first, and the motor doesn't work then, and it doesn't run, and then the other program doesn't run because it didn't finish spinning.
Yeah, I mean, there's always a risk factor when you do stuff like that, but you definitely want to have multiple programs. You don't want to just have it all on 1 program. So maybe like 2 missions, like even like, I wouldn't call them professionals, but there are like college students that do FLL every year. I forgot the name of the YouTube channel, but they do the FLL game just as like fun. They build it in like a day, and they do all of the missions and stuff like that. Even they have their robot come back, because there is a chance of error if you try to do everything at the same time.
Okay.
Yep.
All right.
All right. So let me know if you guys have any questions. Yeah, definitely guys rewatch like the videos and stuff, and maybe think about like stuff you can do for each of the missions, or mechanisms you can build for each of the missions. It looks like, again, the theme is replay, so everything's gonna have to do with like fitness and stuff, and they designed all of the missions as like gym equipment, it looks like. So everything is you kind of like to manipulate everything and like pick up objects and stuff like that, and it's like that every year from as far as I can see.
What was last year's theme?
Last year's theme was this is embarrassing, but I don't remember the exact name. FLL. I should know. Okay, City Shapers. Yeah, that was right. City Shapers. So you have to the mat was like designed like a city, and it had like a park and a swing and a bunch of stuff like that, and you had to go around the city and maybe like pick up objects or pick up like pallets and move them to like the house or the tree or stuff like that.
Oh yeah,
So city-based.
I saw this video where there was this mission and there was this person on a swing and he had to swing it.
Exactly, and that actually brings me to the next couple of videos. So I'm going to show you guys what we did last year, and by we I mean the team I coached last year. Last year was actually my first year coaching FLL. So let me see if I can find a clear picture. This was our robot at the end.
Wow.
And this was the program that I was talking to you guys about. So this was LDCAD. We designed it in the LDCAD program. And this was just kind of like for the design room and like the judging room.
Why is there like 2 random large motors with nothing connected to it?
So that was, if I'm not mistaken, that was an attachment. Oh no, okay, no, this was the lifter. We had like an elevator kind of mechanism. It goes up and down, so it is connected to something. You just can't see it in that picture. So right here, it's the top view. You can see it's connected to this, and that moves it up and down.
There's a touch sensor down there that's being pressed. It's gonna be
so we had 2 touch sensors, 1 gyro sensor, and I don't remember. I have it here. Okay, so we have 2 touch sensors. Okay, so we had a color sensor. So we had 3 large motors, a medium motor, 2 touch sensors, 1 color sensor, and 1 gyro sensor, and of course the EV3 brick. So we used all of our ports. So there's 8 ports, 4 motors, 4 sensors. We used all of those. Yeah, and gyro sensor, of course, was to go straight. Our 2 touch sensors were to kind of like calibrate our robot, because we had like a bunch of different mechanisms. So like we had one here, the elevator, and that moves up and down. So like in a linear fashion. So that went down and hit the touch sensor. And then we also had this little like arm here at the side, and that also hit the touch sensor. And then the color sensor we used to follow the black line. So when we were programming the color sensor, we used it to sort out colors and to like detect different colors. But another popular use, and more often than not, you're probably going to be using it for this, is you see all these black lines? Those are made
You're
Okay?
breaking
So you can use the color sensor. So you're able to, oh, right, am I stable now?
Yeah.
Right. So sometimes like if you're programming your robot, you probably don't want it to like have a bunch of turns. Like you don't want it to say go forward and then go left and then go right. That might be too much, and there's a chance for error if you do it like that. So sometimes it might just be easier. Like if I'm trying to go to this mission right here, it might just be easier to make a line following program, and that'll follow the line.
Oh, and in
And
MakeCode, on the bottom in MakeCode, there's a tutorial on how to do line following.
yeah, so there's a bunch of different tutorials. There's a bunch of different ways you can do it. Some of them work better than others. Some of them don't. But yeah, we had a line following program, and I'll show you guys actually our line following program. And that was to do a mission that was actually exactly where this one is, maybe a little forward. But this map looks exactly like the one from last year. So let me see if I can find the city shapers map. All right. Okay, so this was the map last year. So it looks a lot similar to this year's. So we had like this, it's not really good resolution, but.
You can magnify. There's this tool called magnifier.
Oh, really? Okay. I'm just worried about like the resolution. You guys might not be able to see it well. I think when I opened it in a new tab, let me see if I can download it, if that might be better.
Okay, so just press Control Windows M. Wait, no. Press Windows and then plus, and it's gonna turn on magnifier, and you can magnify whatever you want.
Okay. Hold on.
Windows, just press Windows plus.
Yeah, I did. And it's magnifying, but it's too much.
Oh.
Yeah, it's just the resolution. It's not that good.
I mean, we can see it properly. We can see it properly.
Okay. Really? For me, it looks a little bit blurry.
No, it's fine.
Anyway, but here's like the little semicircle or quarter circle, and that's for that's where you start your robot. And like here, you have a bunch of the lines. I think this year has more of the line following lines. But like I think we mainly used this one that goes straight here. And you might be thinking like, you guys are just going straight. Why do you want to use that? It's because we had to, if you can see here, we had to hit something. And just like bars on the side. So you have to get exactly in the middle of it. And it's hard to see, but you have to hit that swing. Oh. Scam likely. But you have to hit exactly in the middle. So that's why we want to use the line following program, like right there. And I think the mission that we last year had the most challenge with was probably this one right here, the traffic stop. So with this one, you have to actually lift this up. And I'm gonna see if I can find a video on it. Yeah, I think it was called the traffic jam. I just saw it. Oh. This doesn't look like the actual map, but let me see if this video shows it.
Multitasking traffic jam. I saw a video on the bottom.
Yeah, but we had the most trouble with this one. Okay, this one is not showing it well. I'll just find a picture.
Wait, I saw a YouTube video on the bottom, I think.
All right, so yep, it's this right here. And so this one, you have to use the little white, not white, the blue bars, and you have to lift this thing up. But the problem is you have to lift it on, you have to use only the blue stuff. I mean, like, it's gonna be hard to lift it without lifting the blue stuff. And then you have to lift it and push it against the wall. So you have to design your robot in a way that you have a mechanism to do all of that. And so we had a bunch of different ideas. We tried some of them. Some of them worked, but the problem was that they only worked like 1 out of every 5 times we tried it. So we needed something really consistent. And we eventually came up with something that worked actually really well. And I'll show you guys that.
Isn't it like already touching the wall?
No, I mean, like you have to lift this up. So this thing lifts up. It's like a flap. So it rotates like that.
Oh.
Yeah. That's why I was trying to say the
The
video.
jam stops and then it's clear.
Yeah, so it rotates like that. Maybe I think Mr. Hino should have one. And Mr. Hino is really, really useful to watch. He's really good resources to watch when
He's walking to
are doing FOL, because he posts like all the ways that you can do a mission, and he might not use his exact way, but you can maybe find an idea from his way.
If you guys seeing how
Let me just show you guys him doing it so you
more
can see
parallel
what that
block.
mission was.
So let me go ahead and just bring this down.
And he does his stuff with just a basic EV3 robot. We built this.
Okay.
This is the base
So
robot.
that's
So he does his with all of that, with just that. Okay, so do you guys see that?
You've probably seen these in other videos, the curved panels to play tasks.
So you have to find a way to lift it and push it against the side like that. So we did it kind of like how he did, but ours was a lot, our design was a lot simpler. Maybe not our code, but ours was just something stationary, and the robot just ran through it and lifted it up, which was kind of cool. So yeah, so that was our robot last year. Again, we had 2 large motors to drive it.
That robot
yeah.
just looks really complex.
Oh yeah, this was definitely not our first attempt or design. We went through several designs. We changed a bunch of things. Like even up to like days before our competition, we were changing stuff. So yeah, we went through a lot to kind of get this. So your first design probably won't be your last when you're doing this kind of stuff. And that's not a bad thing. It's a good thing, because you always want to build upon what you're doing.
You learn from your mistakes.
Yeah, it'd be kind of scary if your first design was your last, unless it was like really good. All right, so I'm gonna show you guys our robot. So some of the videos might be a little bit different, but that's just stuff we've changed. For the most part, this is how we kept our robot, except you don't see the elevator mechanism, the same one that I showed you guys here, the one at the front. You don't see that in this video. So I think this video is gonna show us the line following program, and it's gonna hit the swing. Oh, yeah, that might be bad. I think I recorded this on my phone and uploaded it to YouTube. My phone has a good camera, but YouTube doesn't. I think it just got clear a little bit, maybe.
No, it's because we're reading it through this.
Oh, yeah, that might be true. For me, it's not that bad. So I don't know if you guys saw that, but it had to hit the swing and have it fall down. And then, of course, it has to always come back to home if you're going to manipulate it or play with it or change, like, the programs. So this is our line following program. So what we had ours do is we first had it drive out, and then we had it use the line follower. So maybe, like, right around here. So whenever it starts to slow down, that's the line follower program. And we had our color sensor on the right. That's why it's kind of skewed to the left. What was that?
The website you were on before, can you send the link to it so we can watch the videos without, like, a flag?
Oh, yeah, sure. Is it really that bad?
Yeah, it's super bad. It's like the robot is moving in pixels.
Oh my God, really? It's not. It looks actually really clear to me. It looks a lot clearer than that picture that you said was good. I'll drop it in the chat.
Well, I mean, it's because you you're screen sharing through Zoom.
Yeah. All right, I just dropped it in the chat if you guys want to check that out. But that was that program. I think we have a couple others. So this was the elevator program, and we had ours go forward. Okay, so ours had to hit this thing and flip it. But I don't know if you can see, the problem that we kind of saw was that if we hit it, if we were trying to come back, we couldn't really come back because it would hit it again and move it back to where it was. So that's why that was part of the reason why we built the elevator mechanism. So this thing moves up. So it moves up and then it's cleared and then it can go back. Yep, and then I think this one is this one does like 3 missions at the same time. So this was kind of like when we were getting really focused on like finishing. So this one is going to do the traffic jam, the swing, and the elevator. So all 3 missions that I just showed you guys. So that was our final like design for the
I
traffic.
honestly would really need I need the link to this video. I have to see it without lag.
Okay. I think I put the first one, but yeah, I'll put this one as well.
What are those green pieces you have on the side?
They're just kind of like panels. The panels. I don't think they are technique pieces. They're panels. We just put that there to cover up the robot. We kind of liked it, kind of like that.
Oh, like clean and
More closed. We didn't want it to kind of be open. That's why you can't really see that many wires as well, because they go under the panels. Yeah, and it might not matter with the wires, like when you're just doing this for fun, but in FLO, you probably want to have your wires just not exposed. You want it to be hidden because that could mess up your robot. And you also get points, especially with like your robot design, if you have your wires tucked neatly into your robot.
Wait, Kuchai, did you put the link in the chat?
Yep. Yeah, I did. And I'll put this one as well, but I put both links. There should be 2. And they might look, they'll just look similar. They'll be all in a row, but if you click each one, wherever you see where it says youtube.com, that's a different link. All right, and this was a video from our actual competition day.
You ready back here on timer? 3, 2, 1, let go!
So when the robot comes back, you're gonna see them like switch out the.
That was good. That was really good.
So we have
Right,
multiple attachments. Everything on the robot now isn't the robot in its like perfect form, I guess. In its basic form. So they're switching it out right now.
That's a good thing in this case.
And so yeah, sometimes this can waste like a long time. Like it could be at least like 10 seconds sometimes to switch out attachments. 10 seconds. What was that?
Very suspenseful.
Oh, definitely, yeah. We're all hanging on the edge of our
Why is he
seat.
trying to reattach it?
You see how long it's taking. So now they're about to drop the little boxes of the pallets at the different areas. And you get points depending on how you stack your pallets. So I think it was by level and it was also by color.
I think it's still fine. Yep. Oh, let's go. It worked.
So yeah, we have to find a way to drop one set off and then still hold another set and then drop that one. That's why you added that
They're gonna get the point. I saw that. I saw that.
Mayport Bridge.
But yeah, I think they spent a lot of time doing that one. But yeah, that was what we did last year. And they were going against, you can't really see it, but there was another team right here. So the girls right here wearing the yellow skirts or the green skirts, they were from the Technical Children's team. So if you guys know the school, James Weldon Johnson.
I'm going to that school next year. Well,
really? Well, yeah, I went to James Weldon as well. My brothers go there too.
oh, nice.
Yeah. But yeah, that's basically kind of like a rundown of
Did
what
you
we
guys
did.
win or did the other team win?
What was that?
Did you guys win or did the other team win?
I don't remember specifically for the rounds. The rounds don't really matter. So the team that you go against when you're actually running your robot, that doesn't really matter. That's just more of for like theatrics. It really just depends on the end, and then they total the scores. But in that specific round, I don't know who won.
Oh.
Yeah. But yeah, it's kind of not irrelevant, but it doesn't really matter who you're going against because like if a team won, if you beat a team, you could still, I guess you could still win overall if you did really good in the other areas. Well, yeah. Did you guys have any questions? That's basically it, and I think we're about to wrap up.